consumer theory. Therefore, we are requiring to solve this problem as much as possible regarding to these micro level applications. The utility, as you are understanding, is of course concentrated to maximizing preferences or reducing the expenditures. Either you are reducing your cost or you are increasing your benefits. Two options we have here, and we are going to exercise interior optimum or expenditure minimization. And then we have some special cases which is very important in microeconomics, such as corner points, where you are giving up to consume combination that you are creating in the scenario, and then you are applying to this application to find the optimal bundle given scenario or given options. Usually we are having two goods, and with this two goods function or option, we are trying to find the best possible option in a given scenario. What we are doing today, we are going to exercise again the consumer preferences. The utility function will be introduced to you a little bit comprehensive, and then the indifference curve. We refresh you again, and the marginal rate of substitution to see how it is going to be realized and applied to the theory, to the cases. And then we are going to find the consumer preferences regarding to this interior optimum or expenditure minimization, or any other cases such as corner points where you are not going to consume any of these goods when the price of this good is going to be reduced or increased and affecting and changing your other preferences or other goods purchasing or consumption. Therefore, these are the concepts that we are concentrating in our lecture, in our today's class. Let me I have to take my pointer then. This will then easily movable for your class. Okay. You know the consumer preferences, because we have to define again the consumer preferences for being able to understand what is it and how we are going to apply to the mathematical methods and applications. Consumer preferences tell us how the consumer would rank. That is, of course, compare the desirability of given options, any two, let's say, combination or allotments of goods, assuming these allotments were available to the consumer at no cost. Therefore, we are trying in any combination to get the best possible option. These allotments of goods are referred to a basket, which we are combining the budget line or budget constraint, and then we are of course using this basket as it is given for the available consumption or the combination in a particular time, in a particular period of time, place under the particular physical circumstances. Therefore, we have to find the best possible option in a given scenario where the ceteris paribus again is applied. Only one parameter can be changed and observed the impact to the economy. For example, if the price is going to be reduced or increased, then we want to see how it is going to apply and change our preferences in this direction. This is the most important part in the economics. As you are understanding, we have to learn and exercise the best possible option in a given scenario. You are understanding? I have here the combination of, again, clothes and food, and there are three different preferences, which is given on point A, C, and B, where one is illustrated at 1 to 5 between units of clothes and units of food, and then C, where the units of clothes is 4 and unit of food is 5, and B, where the unit of clothes is 8 and unit of truth is 1. Therefore, we are having these three combinations regarding to the given scenario, but as you observe here, we are not able to determine which option is the best possible scenario in a given table. Therefore, we have to put on this table our indifference curve and our budget line for being able to find the best possible option regarding to the income that we have and the combination that is given or offered or that we may have as an option. The consumer preferences, as I mentioned to you before, it is concentrated to completeness, where we are trying to find ranked any two basket of goods where B is preferred to A or A preferred to B. Therefore, we are concentrating to these options as it is given to the combination for being able to create our best possible optimal bundle of basket. And each basket should be on the one indifference curve if we have our indifference curve and of course our budget line tangent to each other. And if we have upper and lower level on this curve, then we don't have, of course, the similarities as we are creating in our former lecture, these properties where it is not able to create or offer this similar option in given scenario. The transitivity is also very important, which is the consumer prefer basket A to basket B and basket B to C. Therefore, then if it is A is higher than B and B is higher than C, this means then A is higher than C either. Therefore, this is then of course transitivity, and this will then help you to understand how you are going to create your basket in a given scenario. And monotonicity is of course preferences are monotonic. If a basket with a more of at least one good and no less of good is preferred to the original basket, what is the better? More is better is our scenario and is our preferences, as I mentioned to you. In a given scenario, in a given, of course, bundle, we have to create the best possible option, which is offering us more from the both, which is created and, of course, dependent to our preferences. The utility function is, of course, the numbers to each basket so that the more preferred basket get a higher number than less preferred basket. Therefore, as much as you are increasing, enlarging your preferences, this will create you in a given scenario, depending to your income, bundle or income option, the highest preferences. And utility is an ordinary concept, as I mentioned to you, not cardinal, ordinal concept. And the precise magnitude of the number that the function assigns has no significance and no, of course, contribution to the other scenario. Therefore, we are first creating the more scenario, the highest basket, the optimal basket, as much as we can, and counting it regarding to its given, of course, mathematical application. And when we have this best possible option, then we have the, of course, best possible scenario where the budget line and, of course, indifference curve tangent to each other. As it is given here, we are having here the total utility curve where you are observing is given only one product, which is hamburger. And of course, the total utility of hamburger is dependent to your consumption. And as much as you are increasing your consumption, you are observing on this curve where it is, of course, a nonlinear curve, and it is going to be, of course, to the optimal point or maximum point, and then will become probably the negativity or will go to negativity. Therefore, we have to find the best possible option. As I mentioned to you, this is directly related to your preferences and of your capacity. When you are thirsty, you drink some glass of water, but you are not drinking the whole water because you are probably full up of water and you don't have any more, and this will then damage your health or probably causing some more health problems to you. Therefore, you have to first find the best possible option regarding to this given scenario. And in this example, it is given when you have the total one unit of a hamburger, you have the total unit of hamburger's utility is one, is illustrated as one. And when you move to the two and the third and the fourth hamburger, you probably the utility, as you are observing between one and two and two and three, there are differences, the distance, at least you, when you are looking to the spaces or the distance between these two lines or three lines, you are observing there is a reduction, there is a decreasing amount of increase. It is increasing your utility, but it is of course decreasing amount of increase. It should be probably the similar level realized, and it should be probably at the highest level where you are reaching to the maximum point, but this doesn't mean that you have the highest, of course, the utility as you are getting in the first unit that you are consuming. Therefore, as much as you are increasing and enlarging your consumption, your utility is going to be increased, but is decreasing amount of increase observed. And at A, you are probably the highest utility, total utility that you are observing. And at B, you are again having some utility increase. Yes, please.
Fatima
Yes.
is saying, I want to enter the class, but you are not accepting her.
Which one? I'll say yes. I have. Yes, I have done it. But you try to come point on time because it's sometimes causing problem. Okay. Now you see the PowerPoints. You see this total utility curve, the utility function which is given here. Do you see it? Hussein and Burak and Fatima? If not, then I have you are seeing. Okay. And as I said to you, the utility function here is the root square of y, because we have only one unit of product. Okay, thank you very much for switching off your microphone. As you see, the utility function here is the square root of y, and as much as we are increasing our consumption of hamburger, then the utility, the total utility is going to be decreased. As you see, 1 is higher, goes to 2, which is higher level, and after 2, because probably the 2 piece of hamburger probably you can consume with the similar utility, but after the second it's going to be reduced. As you see, this is probably for any person who is not eating more than 2, and after starting to eat the fifth hamburger or fourth hamburger, his utility or her utility is going to reduce from 2 to 2.24, which is very, very low comparing to, I think somebody is trying to access. Yes, I accept you again, but you should try to come on time. Okay. And this is, of course, the problem in the economy. We have to determine the best possible bundle in a given scenario. And in this scenario, as I said to you, probably after 6 or 7 units of hamburger, when we are going to consume, it is going to reach to the top level where it is the optimal bundle or optimal consumption. And after the 7 or 8, probably it is going to, it's turned to negative. Therefore, we have to learn to create our optimal bundle regarding to the given scenario as much as it is possible. You understand? Okay. Do you have any question? Okay, we have then here the good as a commodity unit which increases the utility, and we have the bad where it is decreasing the utility, isn't it? And we have the neutral where we are not changing our utility. Therefore, this means when you are in the right side, you are having the bad scenario where you have the negative utility, and when you are on the left side where you are having the increasing amount of utility, whether it is decreasing amount of increase, realize your utility is increasing, and where you are on the X dash, then you have the point where you have the optimal bundle. You understand? Therefore, we have to exercise in the economics, especially when we are concentrating to this utility to the consumer preferences. The first, we have to learn that our preferences is limited with our capacity. We don't get much we want. We have the maximum point, and after this maximum, we are going to reduce it. This is totally similar in the production. We have the optimal capacity where you are reaching to the overproduction or maximum production, and then after maximum you are reducing your capacity and you'll become overproduction or surplus, and this will then of course causing your cost is increasing and your benefit is decreasing. Similarly, here in the consumer side of the economy, we have our preferences and
What happened? Does anyone know what happened?
I have to No. Now you're listening me probably. Do you hear me now? As I said to you,
Yes.
the marginal utility. Okay, thank you. Marginal utility is the additional unit that the consumer gets from consuming a little more of X when consumption of all the other goods in the consumer basket remain constant. Therefore, this is then, of course, creating some, of course, problem, which means we are not enlarging our utility as much as we are increasing our consumption. Therefore, we are only able to increase our consumption and our utility, maximizing until the optimal bundle where we are reaching to the top level. When this level is reached, then you are not able to create more, then you will have negative utility. Therefore, this will then, of course, not desired. And we have to find the best possible option for our so-called given scenario. And here, as I mentioned to you in our former graphic, we have, as you are observing, different points A, point B, point C, where our marginal utility is increasing. But as you see, after 4, our utility and, of course, marginal utility is going to reduce. Total utility is increasing, but it is, of course, we have the following graphic. As you see here, there is a decreasing relationship between the utility. Therefore, when we are having this total utility function as the root square of y is the mathematical estimation for the hamburger, we have the optimal bundle until we are into the maximum level or optimal level. And as you are observing here, as I said to you, after 6, we have reached the 7 hamburger with the top or optimal bundle where it is, of course, creating the maximum point for this scenario or for this basket or for this good. And after 7, as you see, the curve is turning to the negative and it is decreasing amount and causing negative utility for our bundle. And as we are increasing and enlarging our scenario, our preferences is going to negative. Therefore, it is not desired. Our utility should be at top level where our maximum point is reached. And after B, where the top point is not desired. You don't have to go to this consumption. You don't have to do any more this consumption because this is not preferred. And as it is given here, the marginal utility and total utility curve together, you are observing here, we have the units 1, 2, 3, 4, 5, 7, and 6, and we have the total utility 10, 18, 24, 28, 30, 30, and then 28. Again, it is decreasing. Therefore, we have here the maximum point, as it is illustrated here, is the 6. 6 unit of X, assuming you reach to the top level. And this then, of course, illustrated on the graphic where it is, of course, the marginal utility is increasing and, of course, diminishing level of increase is realized up to the maximum level. As you are observing in the below graphic, the marginal utility, as it is illustrated for the total utility curve in the upper graphic, is going to decreasing amount of increase as much as you are enlarging your consumption in the below graphic. And as you are increasing your consumption, your marginal utility is becoming where it is, of course, intersect the x-axis and it is 0. And therefore, if you are insisting to increase your total utility until the, of course, this 0 point, you are having diminishing marginal utility because it is increasing amount of decrease realized Do you hear me? I'm going back to the lecture.
Yes, sir, we hear you.
I don't know, it is interrupted sometimes. If somebody comes and goes, and this is of course interrupting our class. Okay, you have understood this class, this PowerPoint, or you want me to explain? Is it enough? Or do you have any question? Anyway, let's look to this given example or scenario for being able to understand the total utility and marginal utility. I have given here, unfortunately, this is in the book and I couldn't upload this table and graphic to the PowerPoint, and I copy it and put it because I have some calculations here, and we don't have, as you know, the application, mathematical application on the internet. It requires some special tools. As I illustrated here, we have the total utility and we have the marginal utility curve. The upper part of this graphic is the total utility, and lower part of this graphic, you see this graphic? Do you see the graphic?
Yes, Ajahn, we see.
Okay, then the marginal utility, as you see here, is of course used by the equation for the utility, total utility function, the root square of the y, as I given to you in the former example. And we suppose here the marginal utility is going to the top level where it is reach 7, isn't it? Let's suppose we have the y at 4. Then we use the equation. I am just giving you this scenario for being able to understand, to see how this marginal utility and of course the function or the total utility function is parallelly realized. When we are applying this function to this theorem, to this equation, we are having, of course, first the marginal utility, where we are going to get the derivation of this utility function, isn't it? And the derivation of this utility function is 1/2 is, of course, root square of y. And when we are applying to this 4, where 4 is, of course, the number of, let's say, hamburger that we are consuming, is, of course, calculated as 1/2 times 2, then which will be 1/4, and this will then gives you 0.25 as a result for the marginal utility. And when we are looking to the below part of this equation, you see you have understood this, the upper part, or you didn't? You got it, you understand? Do you have any question for this upper part? Do you listen me? You should reply me sometimes. You are understanding? You got the upper part of this equation. Do you hear me?
Yes, Ajahn, yes, we do.
Okay, then the marginal utility in the below part, as I have given to you, is supposed to be the slope, isn't it? Because 2 points on the curve or nonlinear curve, when you will have this slope. And here we have again here as a marginal utility, which is delta u over delta y. And this is then, of course, given here u2 minus u1 and y2 minus y1 on the graphic, where u2 is supposed to be 2.25 and u1 is 2. And when we go to the y2 minus y1 is 5 minus 4, then 5 minus 4 will give you then, of course, 0.20 over 1, then this give you again 0.20 sorry, 25, where we have the marginal utility formula, and of course as a slope we are using it 0.25 for this curve, and of course changing this marginal utility or additional increase on the marginal utility. And the, of course, the total utility where we are applying, we have this similarly the same amount when we are using either the marginal utility application delta u over delta y, or marginal utility as a function which is given, because this is the function which is given as y root square. Therefore, any of these two equations can be used for calculating the marginal utility or changing the utility in a given scenario for the economy. When we have this marginal utility sufficiently analyzed for you, then we have to go to the indifference curve and the budget line for being able to combine this and, of course, put all together to the same direction for being able to understand and analyze the utility as much as possible with this diminishing returns. Indifference curve, as I mentioned to you, is that of basket of which the consumer prefer either X or Y. You are going to combine, and any X or Y combination where it is on this curve is giving you this similar satisfaction. We call this indifferences. We are indifference on this curve combinations. Any combination of this curve satisfy us. Therefore, indifference map illustrates a set of indifference curve of a given consumer bundle or consumer preferences. And as it is given here, U2 is lower than U4, and U4 is lower than U6, and U8 is higher than all. Therefore, if the utility function is supposed to be root square of X multiplied Y is given, then we are understanding that when we put this multiplied equation, we will have the utility as given here, the highest bundle at point at utility indifference curve at 8, where the utility is equal to 8, and of course the combination of clothing and food on this utility 8 is the highest where we are having. But if you have your budget line intersect the utility 4, where utility is equal to 4, then of course you are going to stay on this curve, and you are going to combine your utility function and of course optimal basket on this line where your budget line intersect each other. As you are given here, as you are seeing and given here, we are having here, of course, three-dimensionally illustrated the utility of clothing and, of course, food together on the curve. And as you see, the y-axis and, of course, x-axis is together illustrated. And on the third line, we are illustrating on the vertically the indifference curve, so-called the utility function, which is calculated on 4, 6, 8, and 10. And as you see, the 10 is the highest utility. As you are imagined as a box, where you are full up this box, you got the highest utility. This is something like this. And where it is below or the floor on this box, you have the lowest level. Therefore, we are trying to optimize and maximize our utility as much as we are filling our box with our preferences to increase and maximize our, of course, combination regarding to our budget line, as I said to you. And if your budget line is intersect this U4, U is equal to 4, so-called the 4 unit of utility, then you have to stay there. This is then, of course, your capacity, where your income is able to consume or purchase this much of utility on this given scenario. And the properties of this indifference curve, as I mentioned to you, it is not intersecting each other, as I before mentioned. If it is intersect each other, it is not possible. It is not acceptable. It cannot be intersect each other as a given scenario where you are observing here U2 and U1. If it is intersecting each other, Q and R is, of course, R is higher than Q, and here is S is higher than T, and is, of course, not possible. And A is, of course, equally distributed between U1 and U2. Therefore, we are not able to intersect the indifference curve. It is not intersecting each other because it is not giving the similar the indifference or similar combination when you are concentrating to this T and S or R and Q. Therefore, you have to find a reasonable explanation when it is something happens. This is not possible. And of course, we are going to exercise it in the following classes where we are going to apply the corner points. Of course, when we are refreshing and remembering the properties of indifference curve, as I said to you, it is the completeness. It is lying on a one indifference curve, all the basket of combination, the transitivity indifference curve crossing each other, as I mentioned in the former graphic, and monotonicity indifference curve have negative slope, and of course not thick, cannot be thick anymore. because if it is tick, then of course upper tick, if it is tick, the upper level and the lower level of this tick curve is not equally distributed. Therefore, indifference curve, as I said to you, is not on the same basket, is lying on the same basket, and is not, of course, in the different basket. Realize if it is so, then it means then you are either increasing your income or you are reducing your, of course, price of any, or increasing the price and causing to change your indifference curve. And of course cannot be tick, because when it is tick illustrated, A and B point are not equally distributed and are not equal to each other and not negative. Of course, as I said to you, it is slope of this indifference curve is negative, because when you are going to get more x, you have to reduce the y, or when you want to get y more, you have to reduce the x. Therefore, vice versa each other, you have to reduce any of this combination to get more from the other. Therefore, you either reduce x or you either increase y to make some rearrangement on this curve, or the vice versa, you either increase or reduce it. Then assumption, as I said to you, if it is so, then we have to put this, of course, indifference curve to the budget line where it is before introduced to you. And indifference curve, it is supposed to be both to the origin, close to the origin, of course, and it is convex to the origin, because, as I said to you, it is reducing amount of x or y should be realized for increasing other y or x, vice versa together, for being able to combine this basket. And as it is illustrated here, the combination where it is intersect the indifference curve 2, point A and B, where it is the combination of y and x is the satisfied and tangent to this budget constraint, will give us the optimal bundle in a given scenario, because indifference curve 2 is higher than indifference curve 1. And of course, since your budget line is higher than A and B, and of course, it is better option given to you on the indifference curve where it is higher level of satisfaction realized, then you have to apply and create this basket for yourself, because this will be the optimal bundle for your scenario. What does the slope mean? Slope means, of course, as I mentioned to you, you have to create this, of course, changing points from x and y for being able to illustrate and, of course, analyze this curve as much as possible with the marginal utility, because marginal utility is the derivation of the equation. As you know, when you are applying to this marginal utility curve to the total utility either function, then you will get this similar result, because the marginal utility can offer similar satisfaction and similar changes with the total utility, as I have illustrated to you in the former example. And therefore, the slope of this marginal utility, where marginal utility of x is concentrated, means delta u over delta x, and slope of this y, also called the marginal utility, is the marginal utility for y is equal to delta u over delta y. Therefore, any of this combination will give you the slope either for this graphic, and of course will give you the marginal utility where it is the slope. It is equally parallelly analyzed. And the marginal rate of substitution, since when you want to move on x to increase and enlarge it, you have to reduce y, or when you want to increase y, you have to reduce x to get more y. This means the marginal rate of substitution is decreasing amount. Therefore, we can, of course, define the marginal rate of substitution as the decreasing good x or y that the consumer is willing to accept in exchange for a small increase in good x, so that the consumer is just indifference between consuming the old basket or the new basket, because you are replacing on the same indifference curve. As I said to you, on the same indifference curve will offer you the same basket. Therefore, marginal rate of substitution has also meant negative slope, because it is reducing amount of y or x should be realized for getting x or y, vice versa. Therefore, the marginal rate of substitution is the rate of exchange between good x and good y that does not affect the consumer welfare. You are indifferent of these changes. And this marginal rate of substitution is equal to minus delta y over delta x, because marginal rate of substitution of x to y is marginal utility of x to marginal utility of y. Therefore, marginal utility of x to y should be analyzed, that we are going to analyze to see why it is so. The marginal rate of substitution is supposed to be the equation as it is given here for the utility function is root square of x multiplied y. And as I say to you, a to b or b to a, moving from a to b or moving from b to a, is of course not changing the utility, because you are indifferent on this curve on this change, because you are understanding you are giving up a half unit of y to get 1 unit more for x, or you are giving up 1 unit of x to get half unit of y. Therefore, you are equally indifferent on this curve, because you are having the similar utility at a given scenario. And when we are looking to this marginal utility of x, as I mentioned to you, delta u over delta x, and marginal utility of y is of course delta u over delta x. And when you put this marginal utility of x over marginal utility of y, will give you then delta u over delta y. Of course, this is not equal. This should be like this: marginal utility of x over marginal utility of y is then equal to this, sorry, is equal to this. Then this will then of course will be satisfied. This will then this will then gives you this. Therefore, you should apply this to this curve to being able to understand this application. I hope you understand this. If you have any question, you ask me. If you don't, then I will move further. You understand? Okay, my ghost. When we move further, of course, indifference curve, of course, usually exhibits diminishing rate of substitution. As I mentioned to you, the more of good x you have, then the less of good x you are willing to give up to get a little more of good x. The indifference curve gets flatter as we move out along the horizontal axis, and the stepper as we move up along the vertical axis. Therefore, point A, where we are having the point A, which means the indifference curve is of course more vertical, and of course it is more stepper. And point B, we are having of course more horizontal, and we are having more of course flatter to the curve. And this is then of course implies the indifference curve get flatter as we move along the horizontal axis, and the stepper as we move up along the vertical axis. Then of course, when we are applying this to the Cobb-Douglas, where it is supposed to be utility x and y is equal to a power of alpha and y power of beta, where alpha and beta is supposed to be 1, and it is implying that these of course constant returns of this equation for the Cobb-Douglas is realized if it is negative. If alpha plus beta is less than 1, this is then of course negative returns, and if it is positive more, then this is of course increasing return is illustrated. Therefore, perfect substitutes implies utility x over x to y is supposed to be ax to be ax plus by, and perfect complements is supposed to be utility x to y is equal to minimum ax to by, and quasi-linear, where it is non-linear, but of course not fully non-linear, half-half, ux to y is equal to vx plus by is then of course illustrated, where you are having here this quasi-linear equation. The Cobb-Douglas here, it is given again, where alpha and beta is a constant and is 1, then it's supposed to be ux1 x2 is equal to x power of root square or power of 1 over 2, and x2 root square is supposed to be a and b is equal to 1 over 2, and roots, and in the below given equation ux1 and ux2 is equal to x1 multiplied x3 power of 3, a is equal to 1 and b is equal to 3. Therefore, indifference curve 1 and indifference curve is here illustrated as the perfect direction shown indifference curve 2, where the first one is illustrated, is higher than indifference curve 1 as a given example. When we are applying to this perfect substitute application, you are observing here the utility function is given as ax plus by. This of course is supposed to be as the utility for the nonlinear equation x1 multiplied x2 considered, and u as a linear x1 plus x2 as an example is given. Ux plus y is given is a linear equation 1, 2, 3 for the Cox enlargement is increasing the, of course, similarly the Pepsi combination, because it is linearly illustrated as it is ax plus by, where the a and b is intercept here, and it is linear equation and increasing equally on a given scenario. And if it is perfect complements, as you are observing here, instead of given here ux1 and ux2 is equal to x1 multiplied x2, or ux1 to x2 is equal to x1 plus x2 considered, and of course this example is supposed to be u is the minimum x2 multiply y is supposed to be, of course, right angled or right 90 degrees or right angle realized example observed here, where it is 1 to 1 and 2 to 2 is realized. When you are increasing it, then it's giving up, and of course 1 to 2 and 1 to 3 it goes like this, and the utility function is here is supposed to be 10. And of course quasi-linear, as I said to you, when we are applying, not totally linear, because as you are observing here is somehow not linear, and neither linear nor non-linear. It is quasi-linear equation illustrated here, and u1 is lower than u2, and u2 is lower than u3, or vice versa. u3 is the highest combination of this given scenario, where ux and uy is supposed to be vx plus py, and here is, of course, as you are observing, vx is then given scenario will satisfy the marginal utility for vx, and marginal utility for y is then b as the intercept. Therefore, we are having here the marginal rate of substitution vx over b, and this is, of course, quasi-linear illustration or interpretation. And we are having here the point A, the highest combination for this given scenario. Point B is the intermediate level of satisfaction, and C is the lower or lowest satisfaction in a given scenario. And marginal utility, of course, as a given scenario in the former example, is x1 to x2 is supposed to be the utility function, and marginal utility of this is supposed to be delta u over delta x1, and delta u is, of course, supposed to be marginal utility of 1 if we are going to replace each other of this equation, multiplying each other and then replacing delta u and letting delta u alone, will gives us then marginal utility to 1 multiplied delta x1, and marginal utility when you are multiplying this delta x2 to marginal utility to 2, then you get this delta u, or then, of course, marginal utility changes. Delta u is the changes, isn't it? The change in the utility will give you the marginal utility 2 multiplied delta x 2, where it is the change in x, and of course marginal utility, which is the change in the marginal utility, is realized. And delta u is supposed to be 0. If it is supposed to be is equally distributed, then marginal utility 1 multiplied delta x1 plus marginal utility, because we are putting this together, these two equations in a given sum, because delta u is equal here, and it is, of course, same, because we are supposing that the marginal utility, if it is on the same indifference curve, should be equal, and therefore if delta u is equal and same, then you can put these two equations, marginal utility 1 multiplied delta x1 equal to marginal utility 2 multiplied delta x2 should be equal either. Therefore, marginal utility 1 multiplied delta x1 plus marginal utility 2 multiplied delta x2 should be 0 or should be equal. If it is equal, then it should be like this. Therefore, either this or this. And then when you are going to put the other side of this marginal utility of 1 multiplied delta x1, then should be negative. Therefore, delta x2 over delta x1, which is in the equation given, should be the marginal rate of substitution, and is, of course, negative And as I mentioned to you, marginal utility of 1 is supposed to be negative divided to marginal utility 2, and is of course, this is an of course price change where it should be P1, either P1 or P2, price of the first product or price of the second product, so-called X1 and X2. Should any of these reduce, let's say P1 should be reduced to increase the P2 consumption, because if it is P2 is constant, when it is reduced, and when you are subtracting P1 from P2, instead of course negative, therefore this will then give you the negative, of course, slope or negative sign, which means decreasing amount of increase, and of course marginal rate of substitution implies there is of course decreasing amount of increase among the marginal rate of diminishing returns is realized. And then we are looking here at the marginal utility should be of course illustrated as the root square of x1 and of course the power of x2, then should be analyzed as the marginal utility of 1 is delta u over delta x1 is equal to 1 over 2, because you are going to get the derivation of the x1, and x1 derivation is 1 over 2 x1 minus root square. You can put 1 over 2 root square or 1 over 2 x1 over or power of minus 1 over 2 multiplied x2 to 2, because you don't have to take when you are getting the marginal utility of 1, which means you are going to get the derivation for the x1, and when you are getting the marginal unit utility for 2, you are going to get the derivation of the x2 here, and when you get the marginal rate of marginal utility of x2, the delta u over delta x2 is the derivation equation, will give you then 2x1 1 over 2 multiplied x2, because you are going to now get the derivation for the x2 power of 2, and 2 minus 2 will give you then of course 2 multiplied 2, then because you are going to reduce 2 minus 1, because you have to reduce always 1 when you are going to derivation, isn't it? Therefore you will get these two equations bilaterally, and then you are going to apply this marginal utility and rate of substitution from being able to understand how it is going to be realized, and delta u over delta x1 multiplied delta x1 plus delta u over delta x2 multiplied delta x2 is equal to 0, supposed to, because we said the change in utility on the indifference curve is equal, as I mentioned before. And when it is so, then we are going to have this equation, and when we move this delta u over delta x2 multiplied delta x2 to the other side of the equation, we have then delta u over delta x2 multiplied delta x2 is equal to minus delta u over delta x2 multiplied delta x1, which is equally realized since the marginal utility is equal on this given scenario. And then when we are adding this and subtracting each other, then we are rearranging this as delta u over delta x2 multiplied delta x2 is equal to minus delta u over delta x1 multiplied, then rearranging is again, then this delta x2 over delta x1 will be equal to minus delta u over delta x1 over delta u over delta x2, which we are going to summarize this delta u from the equation. Then we have this as a result, delta u over delta x1 is equal to x2, which means x2 1 multiplied x2 will be x2, and delta u over delta x2 is equal to x1 over x1 multiplied 1, which is equal to x1. Marginal rate of substitution for this given scenario will be delta x2 over delta x1, because these are the given scenario from the former example that we have done it. Delta u minus delta u over delta x2 over delta u over delta x2, because these are the utility function that we are calculating, isn't it? The marginal utility of x1 is delta u over delta x1, and marginal utility for the x2 is delta u over delta x2, will be then equal to minus x2 over x1. Then marginal rate of substitution, when we are replacing this delta x2 to do delta y over delta x, this is of course our testament, minus delta u over delta u, delta x over delta y will give you the minus px over py. Then as a result, we are having here delta y over delta x is equal to minus px over py is equal to marginal utility of x over marginal utility of x, y, sorry. Then you can add this either, and you are going to have this equation as a result of this scenario. If you have any question, you ask me. The marginal utility and the marginal rate of substitution can be estimated in a given scenario, and the utility function is given as x1 and x2, and marginal rate of substitution, since we have it here, minus x2 and over x1, the marginal rate of substitution should be minus 8 over minus 8 over 1 is a given scenario in a given example, and marginal rate of substitution for the point, let's say green and purple, I didn't put any numbers here, then is of course minus x over x, then is of course minus 1. Therefore, marginal rate of substitution from the given calculation, from the above calculation, since the marginal rate of substitution is equal to minus x2 over minus x2 over x1, will then gives you, of course, minus 8 over 1 and minus 6 over 6. Therefore, minus 8 is the result for the marginal rate of substitution, because you have to give up 8 to get 1 unit of this. This is then scenario, and marginal rate of substitution is of course minus 1. Of course, this is of course marginal rate of substitution for the utility function of 36, where x and y, sorry, where x1 and x2 is supposed to be 6 to 6. Therefore, 6 times 6 is 36. And for the 1 times 8 is 8, therefore utility is 8, because the equation is x multiplied is given here, and of course marginal rate of substitution for the first one is minus 8, and marginal rate of substitution for the green line is minus 1, and the utility function for the green line, for the red line, sorry, is 36, and the utility function is calculated for the gray is 8. And from this example, we can derive the substitution effect as it is given here. X1 is supposed to be 1, 2, 3, 4, 5, and x2 is supposed to be 16, 8, 5.34, and 3.2. This is, of course, realized by dividing this marginal rate of substitution of given example is minus x2 over x1. Therefore, minus x2 over x1, when you are calculating, will give you the, of course, minus 8, because we are having here the similar example for the given equation. And for the next, we are having for the 5.323 is, of course, it is 2.7, and for the 4 to 4 is supposed to be minus 3, because you are subtracting from each other. And for the next, the last, you are having this, of course, marginal rate of substitution x2 minus x2 over x1 will be then, of course, 0.2. This is then, of course, convex preferences, inverse relation, and of course decreasing amount of increase realized between x2 and x1 is, of course, suggested in a given example. Of course, when we are having another example, we need to calculate, of course, the equation which is supposed to be in a given example. Suppose consumer has preferences between two goods that can be represented by the utility function is u is equal to x multiplied y. For the utility function, when we are calculating the marginal utility of x and marginal utility of y, you know the marginal utility of x is delta u over delta x, and marginal utility of y is equal to delta u over delta y. Therefore, delta u over delta y is x, because this will then becomes 1 when you go to x. 1 minus 1 is equal to 1, and when you get the marginal utility of x is equal to y, because x, when you are going to get 1 reduced from the derivation, x is x power 1 minus 1 is equal to, of course, again 1. Then we have this marginal utility of x equal to y, and marginal utility of y is equal to x. On the graphic, we are drawing indifference curve associated with the utility level of U1 is supposed to be 128, and the answer to the following questions: does the indifference curve intersect each other, or does the shape of the indifference curve indicates marginal rate of substitution, which means is a diminishing returns? On the same graphic, we are drawing the second indifference curve. U2 is equal to 200. Show how the marginal rate of substitution x to y depends on the X and Y, and use this information to determine if marginal rate of substitution X to Y is diminishing for this utility function. Therefore, we are having this problem and we have to calculate this as much as we can online. And as I draw this graphic as it is illustrated here, we have to draw first the utility function for the first. As you see, the utility function for the first U1 is equal to 128, and we are calculating for the, of course, point G as the X is 8 and Y is 10. You know how it is calculated. You're going to subtract each other and you go to input to the equation, because Y divided to 8 and X divided to, of course, 16, then you will get this, of course, results, because it is like this. And point H, similarly, when X is 16 and Y 8, you are going to do the same again for calculating, because you have to be X multiplied Y is equal to 128, and you have to put either X 8 or Y 16 for calculating each other. Then the connects these points with the smooth line for the indifference curve, and we are illustrating this indifference curve as it is given in the first scenario. For the next part of this equation, we can use this, of course, to show that these points, these indifference curves U1 and U2, where U1 is 128 and U2 200 is not intersecting each other, because since U1 is positive, as I mentioned to you, and X, because U1 is 128 and X and Y is a positive numbers, assuming the consumer is buying positive amount of goods, because in a given scenario this is possible. And if the U1 is intersected the X-axis and the value of Y at that point will be 0. Similarly, if U1 is intersected the Y-axis, the value of X at that point will be 0, isn't it? Because when you are giving any of these the total number of the consumption of X and Y, the other one will be 0. Therefore, if either or X were 0, the value of Y would be also 0 and not 128. Since this is so, then we may say the indifference curve U1 cannot intersect either axes, because this is not possible. Since both positive numbers, it is going to be 0, isn't it? Therefore, the indifference curve U1 is supposed to be, of course, not intersecting each other. Similarly, when applying similar mentality and, of course, logic to the second utility, where U2 is equal to 200, we have a similar application for this example either. Let's look at it, then, and we finish the lecture. Figure also shows that the indifference curve U2 is equal to 200, which lies up and to the right up to the U1, because it is increasing. U2 is higher than U1, isn't it? Because U2 is 200 and U1 is 128 as a numerically, as a number. It is, of course, higher as an ordinary number, is also showing that it is higher. Note that the both marginal utility of X and marginal utility Y are positive whenever the consumer has positive amount of X and Y. Since marginal rate of X to Y is equal to marginal X over marginal utility of Y is equal to Y to X or Px to Py, then as we move along the indifference curve by increasing X to Y, will decrease vice versa for the same logic. Therefore, indifference curve will be negatively sloped. This means that the consumer increases X along an indifference curve, Y must decrease, because indifference curve is convex and it is, of course, decreasing amount of increase realized for each other. When we are reducing Y, this Y reduction will be decreasing amount of increase realized up to the, of course, when X becomes to horizontal axis parallel. Therefore, this should be realized in this mentality, and since it is so, then marginal rate of substitution X to Y depends on X and Y, and we have diminishing marginal rate of substitution of X to Y or X for Y can be illustrated and, of course, presented in a given scenario. Today I'm going to stop here, and next lecture we will go to the optimal constraint, expenditure minimization, and, of course, corner points with some more calculations, some more, of course, estimations. I think today is enough for that much, If you have any question, you will ask me. If not, then I will finish this class, and I will put some examples for you, some exercise for you to do as a homework. If you have any question, please ask me. If don't, then I will put some examples for you as a homework to do for you contribution to the final exam. Do you have any question? Quentin, Irene, Tonga. Do you
No,
have any
doctor.
question? You happy? You are
Yes,
asking me too much
doctor.
question. Yes,
Doctor, I'm
Irene, you want me to
sorry.
put you? No, listen. I put you already in the beginning of the semester as a graduate student. Don't worry. You don't have to worry about it. You are in the list.
Oh,
I know
thank you,
everybody.
doctor.
Don't worry. But you
I'm
are
so
asking
sorry
me
for
sometime.
calling you.
No, no, you call me anytime. No problem with this. But you are telling me that I have done it already. There is no need. No problem. I will do. I am trying to do everything best for you. Don't worry. If you have any question, ask me. If you don't, then let's finish it.
Okay,
Do you have
doctor.
any
No
question? No.
question.
Okay.
No.
Have a nice then. Okay, weekdays and then weekend, because we will never have any more class for this week.
We have
Okay.
exam on Friday, doctor.
Yes, but for the game tour, not for this class.
Okay.
For
Yes,
game tour, isn't it? For game
yes,
theory.
doctor.
Okay. Any question?
No, doctor. Teşekkür.
Okay. Thank you then. Bye bye.
Bye bye. Güle güle.
Bye bye.